fluorescence fingerprint is a set of fluorescent spectra measured at multiple excitation wavelengths. My name is Mito KOKAWA, and I'm from the Faculty of Life and Environmental Sciences. So this method can be used to measure very complex things about food. For example, where they were made, like geographical origin, or how long they were matured, like if you have a cheese, whether it's really new or whether it's been stored for a long time. These kind of very complex changes in foods can be measured with the fluorescence fingerprint. And food is a very complex material. You cannot just explain it from one component. So this fluorescence fingerprint is very fit to measure that kind of complexity of foods. And I plan to use this in different areas of food, apply it to different foods, and try to acquire that complexity of food and use it in different industries as well. I went to a university in Belgium called KU Leuven. This university is renowned for agricultural engineering. And in that lab, they used this method called laser scattering to measure the microstructure of foods non-destructively. This technology has been used in pathology to find out tumors inside the body, for example. You cannot cut the body to find out that tumor, but you can use lasers to find out where that is without cutting your body. It's the same thing with foods. We don't want to cut our foods into pieces, but by using the same technology, we can find out the microstructure, how the texture, maybe something inside that we cannot see from the outside, some kind of rotten place. Those kind of things we can measure with laser scattering. So if you use laser light and you put this into material, the way this light is scattered depends on the microstructure. So if you have a way of quantifying that scattering, you can get some information about the microstructure of the food. And this is a non-destructive analysis. Nothing happens to the food itself, but you can measure how crispy it is or how hard it is using light. It would be very beneficial to put this in line where the agricultural products or foods can pass through it with a belt conveyor, and the measurement can be done automatically, very quickly, so that it can be used more in the industry. One of the new technologies that I am developing right now is called spatially factorized spectroscopy. One of the large problems that we have in the food industry is that we need a lot of chemical analysis to analyze foods. Chemical analysis is when you take a food, you do extraction, you do separation, and you measure what is inside the food. But when you do this extraction and separation, you make a lot of waste that has to be treated in order to put it back in the environment. For example, when you look at a food and it says, it contains this and that, that is the result of a lot of analyses that produces this waste. And spatially factorized spectroscopy is a new way that can overcome those problems of chemical analysis by applying the technologies of non-destructive analysis and creating a new method that is both accurate and reliable. We are working with model samples, but ultimately we want to measure real food samples which are very complex, which have structure, and which contain many chemical components. So we have a big leap between this basic technology that we have now versus the ultimate plan of measuring really complex materials. So we really want to bridge this gap by introducing different technologies from different scientific areas. For example, engineering and remote sensing and medical science. They have a lot of sophisticated technologies. We would like to put them together to develop this new method. I've always been interested in the different aspects of food, its chemical aspects, its physical aspects like texture, and the nutrition, all these different aspects of food. And I think that the technologies that I have been developing through research, they help in evaluating high quality products as high quality, very objectively. It would give a strong incentive towards people in agriculture, the people in the food manufacturing industry, to keep up with their producing high quality products. If we can develop a very good method of really evaluating that high quality.